The question of whether dark matter and dark energy could be byproducts of an undiscovered dimension is a fascinating one that has piqued the curiosity of both physicists and cosmologists. If we imagine the universe as being more than the familiar three dimensions of space and one of time, new possibilities open up. Perhaps these mysterious forces are not anomalies, but instead, natural consequences of hidden dimensions interacting with our own. What if there's more to space than meets the eye? We know that dark matter and dark energy dominate the universe, making up roughly 95% of its total content. Yet they remain invisible to us. We detect their presence only through gravitational effects. Dark matter seems to clump around galaxies, influencing their rotation, while dark energy accelerates the expansion of the universe. So where do they come from? An example: shadow forces from higher dimensions. Imagine our universe as a 2D surface, like a flat sheet of paper, embedded within a larger 3D world. If a 3D object, like a sphere, were to pass through this 2D world, beings living on the flat sheet would only see a circle appear, grow, and then shrink as the sphere passed by. They would never be able to comprehend the full 3D shape. Now imagine our universe is a 3D brain, short for membrane, floating in a higher dimensional space. Could dark matter be the shadow of some higher dimensional matter interacting with our universe in ways we can only partially observe? Dark energy might then be the result of a subtle force, akin to gravity, leaking into our dimension from a higher one, pushing galaxies apart and accelerating cosmic expansion. Why do we suspect other dimensions? Some leading theories, such as string theory, suggest the universe may have up to 10 or even 11 dimensions, most of which are curled up and hidden from direct observation. In these models, extra dimensions could influence how gravity works, possibly explaining why it's so much weaker than the other fundamental forces. Dark matter might be ordinary matter from these extra dimensions whose gravitational effects bleed into our 4D reality. Similarly, dark energy might be the result of energy fluctuations in higher dimensions that cause space itself to stretch. This concept could explain why dark matter doesn't interact with regular matter through electromagnetic forces. It simply exists in a higher dimensional space where it can only influence us gravitationally. Can we test this? Physicists are working on ways to detect higher dimensions indirectly. For example, in particle physics experiments, such as those at the Large Hadron Collider, scientists look for signs that particles are disappearing into extra dimensions. If we could find evidence that these dimensions exist, it would transform our understanding of dark matter, dark energy, and the very nature of the cosmos itself. Could we be like those 2D beings, missing the full picture of a multidimensional universe? The answer may hold the key to unlocking some of the greatest mysteries of modern science.